Hi, my name is Muhammad Azib bin Ilyas. I'm from University Technology Mara, Malaysia. Today, I'm gonna present about my research on topic the effect of interdigital electrode material on the performance of an electrochemically reduced graphene oxide chemi-resistive humidity sensor. Humidity plays an important role in maintaining the Earth's biological system and in the industrial process. Graphene, which is a two-dimensional sp2 carbon nanomaterial, had received a great interest because of its outstanding electrical mechanical properties and fully performed biocompatibility. Electrodeposition technique was used to fabricate the reduced graphene oxide on the IDE. This method has specific advantages and have received considerable attention. Advantages of electrodeposition method are the flexibility, inexpensive, and high sensitivity. For the problem statement, nowadays, the humidity sensor have low sensitivity towards the anomalous change in environment. Next, the humidity sensor that exists today cannot last for a long time. The objective of this research is to study the performances of ERGO on various types of metal such as gold, platinum, copper, and silver with the fixed electrode gap spacing for sensing the humidity. Now, we go to the process that is used in this research. First is the preparation of the RGO solution. Next, we fabricate the RGO solution on the IDE. After that, we do humidity testing on each of the sample. Then, the sample is characterized for their electrical impedance. This is the result obtained in the humidity testing. The graph shows the current time graph for each sample, which are silver, gold, copper, and platinum. The results are discussed in the performances of humidity sensor. First is their repeatability. Repeatability is the ability of the sensor of a transducer to reproduce the output readings when the same voltage potential value is applied to it consecutively under the same condition and from the same direction. In this research, silver shows the best repeatability compared to other metals as the pattern of current time graph is the same throughout each cycle. Next is the stability of the sensor. In this research, silver was better compared to the other metals because the reading of the current throughout each cycle is constant and the sensor drift is small. The work function of silver is smaller than that of graphite. The Schottky barrier begins to form when the work function is smaller. The net transport of electrons from the metal to the graphene resulting in holes being annihilated at the metal-graphene interface. After that, the transfer of electrons from the metal to the graphene contribute to the elimination of the metal-graphene interface holes. The result shows that the positive charge on the metal side and the negative charge on the graphene side would help to balance the Fermi level of the composite material towards equilibrium. Lastly is the sensor response of the humidity sensor. Sensor response is the time required for a sensor output to change from its previous state to a final settled value. The sensor response is calculated using the formula that is shown next to the table. In this research, copper had the best response towards humidity in the surrounding. This is because the electron number of copper are smaller compared to the other metals. When electron number is small, the energy level is smaller. It made it easier for copper to react with water molecule. Other than that, silver shows the lower sensor response toward the humidity of the surrounding. This is because when an electron number of an atom is high, the size of the atom will be bigger. When the work function of the atom is small, which is at 4.30 eV, the size of the atom makes it difficult for silver to react with the water molecule. This is the Nyquist plot of each sample, which are silver, gold, copper, and platinum. These results are obtained in the electro-impedance spectroscopy. The semicircle on the Nyquist plot is due to a resistive and capacitive element in parallel. Copper shows a good semicircle. This is because the relative humidity was low. The impedance of the semicircle increased, and as the relative humidity increased, the impedance increased. The decrease in impedance is attributed to improved electrical conductivity of H3O+ and H+ ion of dielectric films. As a conclusion, reduced graphene oxide was successfully fabricated on various types of metal IDE, which were silver, gold, copper, and platinum as humidity sensor, and were characterized using electrochemical impedance spectroscopy. Copper shows the best sensor response compared to the other metal. The energy level of copper is low, which made the copper easier to react with water molecule. Then, silver shows better repeatability and stability in humidity sensing. This is because the interaction of electron and hydrogen atoms in the water molecule is smoother due to the accumulated electron on the surface of the device. Lastly, copper shows a good semicircle in the Nyquist plot of the IDE sample. This shows that copper had the best absorption rate compared to the other metal. Thank you.